Hi guys, today we're going to learn about integration via partial fractions, specifically speaking when we have different linear factors. Now, fractions which have a denominator that can be factored can be decomposed into a sum or difference of fractions. We will do this three types of partial fraction decomposition. Today we're only going to focus on the distinct linear factors. So fractions which have a denominator that can be factored, and that's the main thing, right? That can be factored, okay, into distinct linear factors. You're going to have a situation like this where you recognize that the denominator can be factored out. So you have that the denominator in this situation can be factored as x minus 3, x minus 2. So you can decompose this, okay, as this situation. Do you see it? Okay, so this will create a system of equations that I'm going to explain you how to set it up in a second, and you're going to solve for a and b, and when you do that system of equations, you are going to have that a is equal to 13, b is equal to -9. Therefore, what you have is that this expression that we have here, or this, whatever you prefer, is going to be equal to 13 over x minus 3 minus 9 over x minus 2. Okay, so as you can see, the two factors, they are different, okay, and they are linear. Why linear? Because the exponent of each factor is 1, okay? So this is the case that we're going to focus, okay, the most important one. There's another two cases that we are not going to focus, okay, in those, but I'm going to show them to you in case that you see them there when you are, doing integrals, okay? So fractions which have a denominator that can be factored into repeated linear factors. It means, for example, this one, you know that it should be x times x plus 1, so you have an x squared. That's what we call repeated linear factors, okay? So when you do this, your partial fraction decomposition is going to look like this, okay? You're also going to have a system of equations, and you're going to solve it to result in something like this, okay? There's another case of using partial fractions, okay? But remember, we're not going to focus on this one today. Fractions which have a product of linear factors and distinct quadratic factors that cannot be factored out. What does this mean? For example, you have this expression, it's already factored out for you, and sometimes in the AP test they are going to give you this already factored out. Sometimes you need to factor it. It depends on the situation, okay? But here, okay, you have it factored out already. Okay, so you can see that x squared plus 4 is not factorable because you are in the real number plane. Okay, so we are not in the complex plane, so you are always working here in calculus in the reals. So you have that this one, it's perfect, but this one is problematic because it's quadratic. Okay, it's a quadratic factor. Therefore, you are going to have a situation like this. So do you see the difference? So please remember that in the AP test, the only one that they are going to ask you about is the distinct linear factors. Okay, so you are going to have a system of equations like this, and you are going to solve it for a, b, and in this case c, okay, and you are going to have this, okay? So now, what are we going to do, and how can you tell that you need to use partial fractions? Because by now we know a lot of ways to do integrals, and that's perfect, okay? But let's see what's the business here on this example. Okay, so this example that you have over here tells you to integrate 4x plus 41 divided by x squared plus 3x minus 10 dx. Okay, so the first thing that you're always going to try to do is use substitution. When you do the use substitution, you use your x squared plus 3x minus 10, and you would have 2x plus 3. But the numerator is not even close to the 2x plus 3. Moreover, you recognize that the 3 and the 41, they are not like even friends. So you are like, okay, so game over with my use substitution. Okay, then the split and conquer, this is not going to fly nicely because you can factor the denominator. Okay, so whenever you can factor the denominator, you are going to use partial fractions. Okay, that should be your second resource. Okay, that's the secret here. So what do you have here? How do we start? Okay, so what we have is that you have 4x plus 41, okay? You are going to divide that, and you recognize that we can factor the denominator. The denominator can be factored as x plus 5, x minus 2, okay? So what you can see here is that I can deconstruct this as a divided by, what's that? X plus 5 plus b divided by x minus 2, okay? So at this point, you are like, okay, now what? Okay. You want to solve for a and b. okay, and you're going to tell me how in the world I'm going to do it. You have done this process in Algebra 2. In Algebra 2, what you were doing here, okay, we're going to get rid of the denominators. How can you get rid of the denominators of this equality? What you're going to do is you're going to multiply both sides of the equality times x plus 5, x minus 2, okay, and you're going to multiply all of this times this, and all of this times this, and all of this times this. Okay, so you're going to eliminate a lot of stuff. I'm showing you here all the steps so you can do it in a second. So what you have here is 4x plus 41. The denominator cancels completely. Okay, so you don't need it anymore. Then you have that a x plus 5, x minus 2 divided by x plus 5 is just a times x minus 2. And then the same thing happens with the b. You multiply this, so you only have the x plus 5 multiplying the b. Okay, isn't that super nice? So now you have the situation, and you're going to tell me, now what? I only have one expression. Yes, I know. But the good thing is that you have your factors, okay? So what are you going to do first? You're going to set if x is equal to negative 5. You're going to tell me where in the world you are getting this negative 5. I'm getting it from the first factor. What do you have if x is equal to negative 5? If x is equal to negative 5, I have that it's going to be 4 times negative 5 plus 41 is going to be equal to a times negative 5 minus 2 plus b times 0, right? Because negative 5 plus 5 is 0. So technically speaking, okay, what you have here is going to be 21 is equal to, what's that? Negative 7a. Okay, so therefore you discover that your a is going to be the beautiful, okay, number 21 divided by negative 7, which is negative, what's that? 3. Okay, so you have your beautiful value of a. Now, what do you have next? If x is equal to 2, okay, you are going to see the situation where you have the second factor equal to 0, so that's why I selected 2. Okay, everything is based on the factors. Okay, so if you cannot factor out that denominator, game over. Okay, so what happens here? You have 4 because you have this expression. Remember, you are plugging all this value here in this expression, in the easier expression that you have, times 2 plus 41 is going to be equal to a times 0 plus b times 2 plus 5, right? So then you combine this. What do you have? This is 8 plus 41, that's a 49, and this is going to be equal to 7b, which is great. Why? Because you know that you pass dividing the 7. So what's 49 divided by 7? The beautiful number 7. So you have this expression, yes? So what is your integral? Let's call your integral star, okay? So you can see it here, and we have space here. Okay, so star is going to be equal to the integral. Okay, so all of this is going to be equal to the integral of, what's that? Negative 3 divided by x plus 5, okay, plus 7 divided by x minus 2. The only thing, be very consistent with, if you call this a and this b, this is going to be your a and this is your b, okay, and then dx. Now what do you see here? What we see here is super nice. Why? Because this one, you know that you can do u substitution and you can use natural log, because this is a linear factor, right? They are linear. Okay, so do you see the u of this one? Yes, u is going to be x plus 5, therefore the u is that, so just pull out the negative 3. Okay, so it's going to be natural log of what? Negative 3 natural log of x plus 5, okay, and then you have the plus 7 natural log of, what's that? X minus 2 plus c, and guess what? We're done with this integral. Isn't that beautiful? Now let's go over another example so you can see the situation, kind of like worst case scenario. Okay, so you tell me here, well, we have the integral of x squared plus 2x minus 1 divided by 2x cubed plus 3x squared minus 2x dx. Okay, and you're like, oof. Okay, you try your u substitution. Do you have a 6x squared plus 6x minus 2? And the answer is no. Okay, so what are we going to do here? Okay, you can recognize that the denominator can be factored out pretty nicely. the first thing that you see here is that this is going to be equal to, well, I'm going to write it here, it's the same, so go for it. I can have the x, and then you have 2x plus x squared plus 3x minus 2, okay, and all this is your denominator, the x, right, and we can factor it even more, okay. Why? Because now you have a quadratic there, so what are your factors here? You have that it's going to be x plus 2, and then since you have the 2 there, is 2x minus 1, okay? So you have all your factors there, okay? So how many we have in this situation? Oh no, we have 3. Doesn't matter, okay? So what do you have here? Let's write it here. So you have x squared plus 2x minus 1, all of this divided by x times x plus 2 times 2x minus 1. And you want this to be equal to a divided by x plus b divided by x plus 2 plus c divided by 2x minus 1. Okay, so you have the 3 factors there, 1, 2, 3. Okay, so what are we going to do now? We're going to multiply everything, right? Everything times x plus 2, 2x minus 1. Okay, so you're going to multiply everything. What are you going to do here? X squared plus 2x minus 1 is going to be equal to 8 times this one. Since you are multiplying all this monstrosity here, the only one that cancels is this one, so you have that a is going to be times x plus 2 times 2x minus 1. The b, you can see that the only one that cancels is this one, so the x and the 2x minus 1 stay. Then you have the plus c, okay, times, and everything this cancels, but the x stays and the x plus 2 stay. Okay, so you have a situation like this. Now you're going to tell me what are we going to do with this ifs. Okay, so what you're going to have here, you start with the first factor. If x is equal to 0, y 0, because you have that your factor is x. Okay, so you equalize it to 0. Okay, so it's going to be 0. Okay, so you plug 0 squared plus 2 times 0 minus 1. What do you have? That it's that minus 1, right? And then you have here, okay, so you have that a times 0 plus 2, 2 times 0 minus 1, okay, and then this flies to 0 and this flies to 0 because you have the 0 here and the 0 here, so I don't even write them. So you have that negative 1 is going to be equal to what's the situation here. You have that this is 2, this is negative 1, so it's negative 2a. Therefore, a is going to be equal to 1/2. So you have your a. Now, if x is equal to, go to the next factor, okay, so you don't forget about any of the factors. You equalize your factors to 0, so you know that it's negative 2. Okay, so if I plug negative 2 here, so you have negative 2 squared plus 2 times negative 2 minus 1. This is going to be equal to, and you can go ahead and see, well, this one and this one, they are going to disappear, so the only one that I care about is this one, because you have a 0 here and the 0 here when I plug the negative 2. So be efficient here. Okay, the idea here is that this method of integration helps you to make it faster, right, and more efficient. So you have a situation like this. So this is going to be 4 minus 4 is 0, so you have negative 1 is going to be equal to, and this is going to be a negative 2, and this is going to be negative 4 minus 1, that's going to be what? Negative 10. Okay, negative and negative, excuse me, positive. So you have no, that's going to be, yeah, positive. Okay, so b. So what do you have here? You have that b is going to be negative 1 over 10. Okay, so you have that. Oh no, we have fractions. It's okay, we'll do it in a second. Okay, so the third option that we have, if x is equal to, oh no, we have 2x minus 1 from here, or from here, wherever you want to see it, right? So you have that x is going to be equal to 1/2. So what do you have here? So you would have 1/2 squared plus 2 times 1/2 minus 1 is going to be equal, and you can see that the factors, this one goes to 0, this one goes to 0. Okay, so the only one that we care about in this one is going to be that one. So you have c times 1/2 times 1/2 plus 2. Okay, so what you recognize here is that on this side, what do you have? You have that this is going to be 1/4 plus 1 minus 1, so this is going to be 1/4. And on this side you have that it's c times 1/2 plus 5/2, so you have that it's going to be 5/4 c, right? Therefore, what do you have that it's your c in this equation? 1/5. Do you agree with that? So what do you have here? What we have is that star, okay, let's call this one star. What's going to be star? It's going to be the integral, okay, and let me make it big, of a, which it was 1/2, so I put it here, okay, if you want, x, okay, minus, okay, 1/10, put it like that, x plus 2, okay, and then you have plus 1/5, okay, 2x minus 1, close it, dx, okay. What do you have here? A bunch of logs, okay. So what do you have here? It's going to be 1/2 natural log of absolute value of x minus 1/10 natural log of absolute value of x plus 2. Now here, be very careful with the 2x. Why? It's sneaky. You were doing the u substitution automatically here because the u was x, the derivative is just dx. Okay, here it was just 1, but this one is 2x, so we need to complete that too. Okay, so you need to divide the 1/5 times 1/2 because of this, because you have u is 2x minus 1, the du is going to be 2dx. Do you see it? I don't have the 2, so you need that half. Okay, so it's going to be 1/5 times 1/2 is going to be what? 1/10 natural log of absolute value of 2x minus 1, and then your plus c, and we're done. Isn't that beautiful? The only thing, be very careful when you have linear factors with the leading coefficient different than 1. The only problem that you might have is that you need to do the u substitution more carefully. Instead of doing it in your brain, you might need to write it down, but don't worry. Okay, so that's it for this example. The next example that we have here is the integral of 7x divided by 2x minus 3 times x plus 2 dx. Okay, so this is a multiple choice question. So they already gave you here the factor that out situation. So they are giving you a lot of steps, which is very nice. So what do you have here? You know that this, okay, you know that 7x divided by 2x minus 3 times x plus 2 is going to be equal to a divided by 2x minus 3 plus b divided by x plus 2. Okay, please remember the main thing, you are going to tell me I put the factors backwards and I put the a and b. You are going to have the a and b flipped, but the result is going to be the same. So don't worry, as long as you're consistent, you are fine. Okay, so now what are you going to do here? We are going to multiply both sides times the two factors, 2x minus 3 times x plus 2. Okay, so what do you have here? You are going to have 7x is going to be equal to a times x plus 2 plus b times 2x minus 3. Okay, yes, happy. Okay, so what do you have? You have that if x is equal to, which one do you want first? -2. Okay, so if you have that x is equal to -2, you have 7 times -2 is equal to b times 2 times -2 minus 3. Okay, yes, no, sort of, happy. So what happens here? You have that this is -14 and this is going to be equal to, that's -4 minus 3, that's -7b. So you have that b is going to be equal to +2. So then you have, go ahead, if x is equal to, what's that? 3/2, because that's the other factor that we have here. So what do you have here? You have 7 times 3/2. It's going to be equal to, and you know that this one goes to 0, so it's only the 8 times 3/2, what was it, plus 2. Okay, so what happens with the a? You have that this is going to be 21/2 is going to be equal to, what's that? 7/2 a. Okay, so the 2's cancel, so what do you have? That it's going to be your a. you have that it's 21 divided by 7, which is 3. So you have your B and you have your A. Oh, we didn't have them in order. It's okay, as long as you are consistent with what you have here. So let's call this one. This one that we have over here, you know that that one is going to be equal to the integral of what? A, which is 3, divided by 2x minus 3, okay, then you go plus B, which is 2, divided by x plus 2, close it, dx. Are you okay with that? Let me call it star so we can go ahead and put the result here. So what's going to be star? What's going to be here? Okay, the situation. Be careful, you have that too. Okay, so you know that that integral is going to be 3. Okay, and what's going to be the situation that you need to be careful? Okay, you need the 2, okay, because u, again, remember, u is going to be 2x minus 3, du is 2 dx, and you don't have the 2, okay? So what you have here is you are going to divide by 2, okay? So you have that it's going to be 3/2 natural log of, what's that, 2x minus 3. Okay, so then you approach the next one. Your u substitution here is easier because it's x plus 2. The du is just 1, so respect the 2 that you have in front. Okay, so you have the 2. Okay, then it's going to be natural log of x plus 2 plus c. Okay, now, do you see this answer somewhere? Yes. Okay, so you have the answer in A. Okay, now, what happened here? What the student forgot over here? The student didn't do the u substitution correctly, and the poor student was very close to the answer, but what happened? They forgot the u substitution, so be very careful here. Okay, so again, here you can see the 3 there. Okay, here the student, they messed up on the sign of the second term, right? Do you see it? And this one, well, the student just, it was just at the beginning. So these two, they are a no-no. Okay, this one, the poor student, they don't know what to do here. Okay, it seems. Okay, but you can see that this one is very dangerous because if you don't do the u substitution correctly, even with all the work that we have done, you are going to arrive to the incorrect answer. So be very careful. This, no, right? Excuse me, no, this one is the no. Okay, that one, yes. The other one, the one that was no, it was here. Okay, so that's for partial fractions. Okay, so please remember that the one that we're going to cover here is going to be partial fractions using different linear factors. Okay, so I hope that you find this video helpful. Bye.